Good morning, afternoon, or evening. We're going to give 5 or 10 minutes for people to kind of funnel in, and then we'll get started. Is there a superset community in Maryland? It's kind of interesting. Like, I feel like whenever we ask where people are from, there's always people that are like Maryland specifically. I'm kind of curious about that. It's just, they're the only superset user in Maryland. Yeah, Mark is just like an extremely regular attendee. Great. Cool. No, don't be sorry. It's great to have you here. So we're probably going to get rolling about 10, somewhere between 10:05 and 10:10. So feel free to grab a cup of coffee or get some water, stay hydrated. Just let people kind of funnel in. For sure. All right, still got people coming in. Let me just ask a couple of questions here. I'm a little bit curious. Is anybody here currently using Apache Superset with like a data lake architecture? Like, is anybody connecting Superset to like Athena or Presto or some other like data lake focused query engine? If you are, say something in the chat. I'm a little bit curious to see. Teradata.
Max asks if BigQuery is considered a data lake.
It's an interesting question. I would kind of consider it to be. I mean, BigQuery has like that really nice advantage where you don't pay for storage, you just pay for access. I feel like BigQuery is a data lake. At least it can be used that way. That's kind of interesting. I'm not actually sure exactly what BigQuery supports as far as like being able to query inside of semi-structured data like JSON and Parquet formatted files and stuff like that. I haven't worked too much with BigQuery personally, so I don't actually know what it supports there. If you're just joining, it's good to have everybody here. We're going to give it another 3 or 4 minutes, and then we're going to get started. Kiran asks if there's any API for visualizing a SQL Lab query as a chart or dashboard. I'm not sure I fully understand. You're saying like you want to provide a query via the API and then have it like represented as a chart? Or that you want to use the API to like trigger a saved query to refresh the data underneath a chart? It's like not fully clear exactly. Oh, okay, Max wants to be summoned. I will summon the great one. I will summon Max to address your question. Hang on one second. Welcome, Max, original creator of Superset. Join us.
Hey, yes, I was interested in my own question, which is like, can BigQuery be considered a data lake? And then I went onto my BigQuery instance here to see the supported file format. So when you create a table, as you create a data set in BigQuery, you have a bunch of options. And then I was looking at all the options, and one is GCS, and it decomposes in different file formats. So you have CSV, JSON L, which is new line delimited.
Oh no, we lost Max.
So we have one of my old friends from my grad school days in the audience.
Well, you think we should get started then?
I think it's probably about time. Okie doke. Well, hi everybody. Glad to have everyone who's here. I'm gonna talk about 10 minutes. We're just gonna go through like sort of a brief agenda and some background for people that may not be quite as familiar with the technologies we're gonna be using today. We're gonna go on to AWS and talk about like resources a little bit and show a few things about AWS Athena and AWS Glue. And then we're gonna pop over into Superset and show how basically working with data that's stored in a data lake through Athena is, from the perspective of Superset, very similar to working with any other SQL speaking data source, and you can do a lot of the same great stuff. So if you have questions, I'm going to pause maybe in the middle, depending on how we're doing on time, but definitely at the end, we'll have an opportunity for questions. So feel free to put questions either in the chat or in the Q&A. I would recommend in the Q&A, it'll make sure that it gets addressed. And Srini and possibly Max will be helping me sort of answer questions and wrangle topics as we go through this. I'm going to share my screen and we will get started. Hold on one sec here. All right. Are folks able to see my screen okay?
That's great.
Awesome. Okay, how's it going, everybody? My name is Robert. I am an employee at Preset, and we're talking today about visualizing a data lake with AWS Athena and Superset. So let's hop right in here. So first, just a little bit about me for those who don't know. I'm a data engineer. I'm also a developer advocate at Preset, which is the company that is commercializing Superset. I build predominantly open source data stacks at Preset, and I would consider myself to be a little bit of an architecture nerd. I really like data architectures. I like talking about them. I like thinking about them. I like learning about them. So today we're going to be, part of our discussion today is going to be largely architecture focused. And I'm pretty excited to get to talk about this stuff. So just a little bit of basic agenda. We're gonna get a little bit of basic background on data lake architectures, what they are, what motivates them, why you would want to use them. We're going to talk about configuring two different AWS services, which is Glue and Athena. We're going to leave like all of the detailed configuration out of this talk, and instead I'm going to just put up a blog post that actually walks step by step through the configuration of these services. And then we're going to talk about how to connect your data lake to Superset through Athena. And then we're going to play around a little bit with data that we have in sort of a sandbox data lake in Apache Superset. Like I said before, feel free to ask any questions as they come up, and we will definitely get to answering them at the end if we don't have an opportunity to stop midway through to take questions. So first question to start with, what is a data lake? It's kind of like maybe an ill-defined term in some sense, but I'm going to take a crack at defining it. So if we rewind a little bit, the traditional data warehouse architecture looks a little bit something like this, where you have data sources, you have some ETL tool, and then the data goes into your data warehouse, and storage and processing and access through SQL queries are all coupled together in your relational database system. ETL tool could be an actual specialized tool. It could be a series of scripts which are retrieving data from APIs. In any case, this is like a sort of a very old way of thinking about organizational data. And if you're curious where these figures are coming from, I borrowed a couple figures from a book that I really enjoyed a lot, and I would highly recommend to anybody that's sort of interested in learning more about cloud data architectures. It's called Designing Cloud Data Platforms by Daniel Zbrevsky and Linda Partner. So I'd recommend checking that out. So there are a few factors that sort of pushed data architectures away from this model. One was the need for scalability to just match a growing amount of data that was basically coming into organizations through the internet. The second is sort of an increase in the amount of unstructured data and semi-structured data that is both being generated by organizations and also needs to be analyzed and accessed. So for those who don't know, semi-structured data would be things like self-describing document files. So like JSON formatted files, Parquet files, stuff like that. Unstructured data could be things like multimedia, images, video, stuff like that, or documents that don't have a predictable self-describing structure. So those factors are really important. Also, data science and machine learning use cases often require direct access to data. So machine learning models sometimes need to directly access data, like a natural language processing model might need to access large quantities of text, or a image classification model might need to access a bunch of raw image data. And that's not really possible through a traditional data warehouse, because data warehouses are really built to store and serve up structured data. Also, there are, as more data science use cases emerge, there is a growing need for data scientists to be able to directly access data as well, for quality assurance purposes, for the reasons of understanding the data, and a lot of times because the things that they build require direct access to the data. A fourth factor is that there were a number of technological advances that happened starting back, actually, I think around the time that Max was at Facebook. There was a technology called Presto that emerged during that time that essentially provides a horizontally scalable SQL interface for all different kinds of data that's stored in relational systems, data that's stored in NoSQL systems, and now in the more modern sense, data that's stored in like a cloud data lake. So obviously the technology had to be there to enable this architecture. And then also, in general, it's just a better fit for the more kind of like loosely coupled emerging cloud data platform. And I want to talk about that idea just really briefly here. So I borrowed this figure from, again, Designing Cloud Data Platforms, great book, absolutely recommend checking it out. But essentially, what I want to highlight here is that batch data comes in here. There's some kind of ingestion that happens to bring the data into your data platform. And then the data ends up oftentimes in slow storage or some kind of direct data lake access. And you need to be able to get that data to data consumers like Superset. So every cloud platform has their own version of these services built in. And there's also cloud independent technologies that can be employed in all of these different slots. But for AWS, it's these things. So for dealing with batch ingestion, AWS provides Glue, DMS, Lambda can all be used to do that. We're going to talk about Glue today. For storage, AWS S3 is really well known and widely used. It's an inexpensive way to store large amounts of data. It's not particularly fast is sort of its limitation, but I think it's like very widely used these days. And Athena provides a sort of like SQL query interface on top of data that's stored in S3 that can then be taken advantage of by data consumers. And Glue can be used to sort of like do a lot of things actually, but coordinate the whole process is one of those things. So talking very briefly about each one of these technologies, Athena is a serverless query engine. It's based on PrestoDB. It connects to file storage, so S3, other SQL-speaking data sources that you might have in the cloud, which include both Amazon services and also things you may have set up yourself, as well as AWS Glue, which is how we're going to be using it. You can manually define external tables on data that's stored in S3, although this is not how I would recommend probably doing it for a few different reasons that we'll talk about. Or you can use Glue to crawl and catalog data automatically. And that's the, in my mind, sort of the preferred way. And that's what I would like to sort of highlight and direct people towards doing. Glue has some really nice features for being able to automatically detect changes in a S3 directory, automatically update the schema of files that you have in S3, like suppose you add a new column to some CSV or something, Glue will just automatically update that schema, and then it'll get handled automatically downstream when you try to query it in Athena. And it also provides like a metadata catalog. And then it's also very cost effective compared to a traditional data warehouse service. You pay per query with Athena, and the data is stored very inexpensively in bulk object storage like S3. So that's good stuff. Glue, we already kind of talked about. We're going to move past this, but basically it provides a sort of a global metadata catalog. Built-in orchestration, you can schedule it to run when files in the S3 directory change. You can have it run on a fixed schedule. You can run it manually. Also, Glue automatically defines and updates schemas for semi-structured data, which is really nice. It's way better than like trying to define schemas with like create external table commands in SQL. And then Apache Superset, of course, which we all know and love. It's an open source data visualization and BI solution. It works with almost any SQL speaking data source through SQL Alchemy. And it basically provides a couple features that are really useful for working with data lakes. One is query caching and the lightweight semantic layer. Particularly the caching part is really nice. Data lakes are accessing data stored in the data lake through Athena can be quite slow because the data is stored in a very slow storage, and Athena itself is not particularly fast. So being able to cache the queries in Superset can provide you with much more responsive analytics. Also, the SQL IDE, which is built into Superset, and Explore mode, which lets you sort of visually play around with data and creating charts and things like that, both provide sort of an excellent vehicle for working with data that might be stored in a data lake. So let's talk really briefly about one thing that's relevant to connecting Athena to Superset, which is the connection string. So in Superset, when you want to connect it to a different database, like various different database technologies, you have to provide a connection string, which tells Superset essentially where to find the database that it's connecting to and how to connect. I'm happy to say that I think one of the things that we're working on is sort of redesigning the database connection experience to make it a little bit more intuitive and like UI oriented. But for now, the connection string is how you connect. And AWS Athena has one of the more complicated connection strings that's available through SQL Alchemy. So I just wanted to talk about it really briefly, talk about each part of it. There's actually two different drivers for AWS Athena through SQL Alchemy. There's a JDBC driver, and then there's a Athena like a REST API that essentially, I believe it's like a Python wrapped around the JDBC driver, and it is definitely the preferred way to connect. So I would recommend using this one. This is oh geez, wow, how did that happen? This is essentially like the key ID that was generated from an IAM user with the necessary permissions to access Athena. And then these X's would be whatever your secret key is. You need to provide the region that the S2 bucket that stores your data is in, as well as the name of the database that you've created in Athena. That's in green here. And then you have to provide the staging directory in S3 for Athena as well. So, and there's a couple constraints here. One is that this needs to be in the same region that you see in green. So you can't have it staged in an S3 directory that's in a different region from the region that the Athena DB is in. And then you also have to provide a work group. One other thing I want to say about this light blue string here is that this is the staging directory. So when you configure Athena, you tell it where it's going to stage its data. That's what this has to be. This is not the directory where your actual base data is stored in S3. So that seems to be a common misconception. And I just wanted to make sure that we're totally clear on what all the different parts of the connection string are. I'm going to go into this in the blog post as well, so don't feel the need to like write this down. But I just thought I would show this because this is one of the more complicated connection strings, and it can be a barrier to getting Superset connected successfully to Athena. So let's talk a little bit about some of these cloud resources. I'm going to close this down, and we're going to pop over here. And we're going to go in here. And first, we're going to talk about S3. So here I have an S3 bucket that I've created to essentially demo some stuff. And you can see that we have a few different directories that I've created here. One is an Athena directory. So this is the directory where Athena is actually staging the data. I recommend creating a new directory in your S3 bucket to do this rather than trying to store it like in the same directory that your data is in. It's going to cause all kinds of problems if you do that. So just make a new directory. And then when you specify the location for the Athena database, just select that directory. Another recommendation that I have that I think is a pretty good best practice around Athena is if you're working with files that have different schemas associated with them, separate out and isolate those different files in subdirectories that are schema specific. So don't have two different CSV files with different schemas in the same subdirectory that Athena or Glue more specifically is looking at. What I found is that it can cause some weird issues with actually executing queries against that data. So what I have done here is, if we go into DevRel datasets here, I've created a subdirectory for each one of my data files. And that is what I would recommend. I would definitely recommend doing that. And another feature that we're going to explore that's like really useful about this architecture is that if you configure Glue to automatically crawl your S3 bucket, then what's going to happen is every single time you make a modification in that directory, you can configure it so that Glue just crawls those changes, which is both cost effective and also means that the only thing that has to happen for new data to appear in Superset for you to analyze is that the files have to appear in the S3 bucket. There's nothing else. Glue will take care of crawling the file, generating the schema, and adding the data to the metadata catalog. Athena will provide queries against that table automatically. Like, it's great. It works super well. So what we're going to do is we're going to take this serial.csv file and we're going to move it using the interface. I know this is really painful if you're used to using the CLI for AWS. So my apologies if this hurts you. So we're just going to move this into DevRel datasets, and I've created an empty directory for it. So we're just going to move it in there. Yes. All right, so we just moved a new CSV file into the directory that Glue is looking at. Now let's go over and take a look at Glue really quick. So here we are in Glue, and Glue is, by the way, a super feature-rich piece of software or like service. It does a lot of different things, but what I really want to focus on today is talking about the crawlers. So crawlers basically connect to your data store and essentially crawl the files that are in an S3 bucket. or another data source that you're interested in. So I've created a test crawler here just for demonstration purposes. It's basically set to point at this DevRel datasets directory and everything that's stored inside of it. So if I hit run crawler here, it's going to take about a minute to run the crawler. I have it set to run manually just because it's for demo purposes. But if this was an actual data lake and you were cataloging it, and let's say you had some operational system that's like dumping logs into some directory in your data lake, you could have Glue automatically crawl those logs as they're added, and the data would essentially be available in Superset for analysis with very little delay. So while this test crawler runs, we can move on and talk a little bit about Athena's configuration. So here we are in the Athena console. You have the ability to generate and run SQL queries against your tables right here. You can have different databases, but for the data source, you have only two options. You have an account-wide AWS data catalog, which is connected to Glue. That's the data catalog that basically Glue puts, it's the Glue metadata store. Or you can set up a custom one in your AWS resources in a different way, and we're not going to worry too much about that. So what's going to happen is that within a few minutes, our new table, which corresponds to this serial.csv, is going to be added under tables, and we could run queries against it. But instead, we're just going to let it appear on its own, and we're going to go over to Superset. So here we are. This is Preset Manager. So this is our company's service, but essentially all of these are just Superset workspaces. So I'm going to pop into this new one that I created for Athena. Here we are. So here we are in Superset. This is the Superset that everybody knows and loves and is familiar with. We're going to go over to databases, and if we wanted to add, you can see I've already added Athena as a database here. But if we wanted to add it, the way that we would do it is just by taking that that connection string that we talked about earlier, which you can check out the documentation for right there, and you just paste it in here. You give your data set a name. There's some advanced options which are don't need to be configured, and you hit add, and then it'll add it as a data source. And then if we go over to data sets, let's see, we can filter by database. And we can say add a new data set from Athena. So these are all the different databases that are created in Athena. This is the one I created for this demo. And then you can select, there it is. It looks like in the time that it took us to get over here, the Glue crawler finished crawling the CSV file, and Athena has created a table that represents that file. And basically we can add it as a data source. Dunzo. I tried to add it twice. That's what that was. And then if we go over to SQL Lab, this is the built-in SQL IDE that's in Superset. We can select that schema, pull up that database, and we should be able to run a query against that data. And there it is. We can see all kinds of information about various different breakfast cereal and their nutritional content. So if we go over to charts, we can say, let's make a new chart. We can choose a data set. So essentially, like once we've reached this point in the process, when you've set up Glue, you've set up Athena, and you have your data automatically showing up in your S3 bucket, you essentially can be completely hands-off with this architecture, right? The data appears in the S3 bucket, operational systems just put it there. It gets automatically crawled by Glue, and then it's available automatically through Superset connected to Athena. So we're going to go to, actually, let's pull up this other data set. And let's make a pie chart. And let's group by continent. So this is like just like a small chopped down little COVID data set that shows essentially cases by geographical location. And you can see that we can run queries in a relatively time efficient way against the data that's in our bucket. So I think this is maybe a good time to open it up a little bit and maybe address some questions. I'm gonna stop sharing my screen really quick just so I can see the chat here. Oh yeah, we are going to post the recording for this later, so don't worry about missing stuff. We're going to put that on YouTube. Can I share a PyAthena JDBC example as well? It is, I believe, I'm not sure exactly what you mean by that. I think the PyAthena JDBC driver is the one that we're using when, or like that's what we're accessing when we're using the Athena plus REST prefix at the beginning of the connection string. So maybe this was that example. I'm not sure if what you mean by that. Maybe clarify a little bit.
I think that was so the Athena AWS Athena plus REST is the PyAthena library. It is not the PyAthena JDBC.
Okay.
So if you
got
quickly click that link I just shared, they're similar, but they're a little bit different. Yeah.
Thanks, Srini. I see someone has mentioned that the Athena connection string does support session token as well. That's true. Yeah, there's a lot of different ways of setting up security in AWS to access your resources, and a session token also does work. Quote plus or equivalent is needed for a secret, and S3 staging dir. Yes. I am testing connection to my local Docker. I get error, could not load database driver Athena engine spec. There may be in standalone Superset a driver that you have to install. I don't know if maybe Max knows about this off the top of his head, but I can tell you that in preset we have all of the drivers for all the databases like pre-configured and running. So that's one of the reasons why I'm using preset. Max, do you know off the top of your head if there's like an extra package or something that's needed to get the Athena database engine driver?
Yeah, so I think in the base Docker image, there's no drivers installed because we don't want to pollute, your Docker with a million drivers you might not need, and some of the drivers have licensing issues associated with them. They're not Apache compatible licenses. So, but we have somewhere a list in the documentation of the officially supported databases and what the name of the recommended driver for that database is. I'm guessing that there's probably a pip install superset bracket Athena that would do that. I'm going to check real quick. But yeah, so we have these like shortcuts and our extra requires. I believe that makes it kind of convenient. So yeah, if you write the command, I'll write it in the chat now. But pip install superset brackets Athena. So that's like an extra Athena here is yeah, here it is. So we recommend this specific driver in that version range.
Awesome. So that does answer that question. There's a question that popped up in the Q&A that I want to answer, which is, can I share my connection and dashboard to other users? And the answer is yes, absolutely. If you're working in the same Superset workspace, you can essentially have all of your connections and your dashboards available to other users. So
yeah, that's definitely like the default behavior, right? A database connection is kind of a global that is in your Superset environment and can be used by everyone who's given access to it. So there's a way to even restrict and say some people can only use certain database connections, certain schemas within that database connection, or certain tables within that database connections as well.
Yeah, I think that there was an interesting question that came up in a discussion that I was in with some other open source data people a few days ago, which was like, what actually defines a modern data stack? Like what does that even mean? What is a modern data architecture? And I think that I've been thinking a lot about that question. And one feature of a data architecture that I think makes it modern is it's definitely like kind of heterogeneous in terms of how things are stored on it. So you might have some logs, other operational data that's getting dumped into a data lake. You have other data warehouses or data marts that are relational and are designed for like sort of like dimensional analysis and things like that. So any like modern analytics layer or modern data tool that's designed for a modern data stack is going to need to be able to access data across a wide variety of different data sources, ideally in as consistent a way as possible. And I think that like Superset does that really well. It's one of the things that I like a lot about Superset. So I just wanted to mention that because it's kind of like a relevant consideration. And yeah, Max is sharing the A16 architecture diagram. Do you want to say something about that, Max?
Yeah, I mean, I just wanted to show A16Z did a good job at looking at modern data infrastructure. They talked to a lot of practitioners in the space and they look at what people are typically using and what are the components. So some things, they try to put a title that's something like, a family of tool like data modeling or workflow manager, and then list out the things that are commonly used in the different boxes. So that post, I shared the link to that post. I think I'll produce. I'm not saying that because they are investors, but I think they really did their homeworks in that area, which led to investments with great companies like Preset.
Yeah, definitely. I don't have much more to talk about. I know that folks here might be pretty curious about a couple things, and maybe I'll just try to address those things really quick. One is, well, what are the details as far as how Athena and Glue and these other AWS services are configured in order to enable like data storage and access in this way? And my answer to that is that I'm going to go into total detail on those things in a blog that I should be posting to the Preset technical blog either today or tomorrow. So I'll ping Slack and paste it in Slack, and also will basically just keep your eye there if you are interested in that information. And yeah, there was something else I was going to say that felt particularly relevant, but it's slipping me. We got a question here. I've used Superset. I have many dashboard, data source, and chart. It's difficult to manage by name in the UI when I search or edit. Do you think we'll add tags to each chart, or is there a more efficient way to manage them? That's something that's definitely come up before. There's been proposals that sort of run the whole gamut of possibilities, from being able to put dashboards and charts into like folders to like more of a GitHub style label system where you could just attach labels to charts. I don't think that we've settled on any like final, like solving that problem, but we definitely there's been proposals, and I would suggest if you have like an idea that's particularly relevant in that area, think about like maybe writing up a Superset improvement proposal about it. And if you're curious how to do that, we got a great blog on how to do that on the Preset blog. Max, did you want to say something about that feature?
Yeah, we do have an item on our roadmap. I think that is a should have and not a must have. So it's a second class of items on our current kind of 3-month run roadmap. And we're looking to probably do some kind of quick wins in this area. I wanted to point out to some of the features that are in Superset today that help curating a list. So one is dashboards can be published or unpublished, which means like if they're not published, they're kind of private to you and they won't pollute the global namespace of other users. There is the notion of certified as well that exists for dashboards, metrics, data sets. And I'm not sure about charts too, but that's an emerging feature where we can kind of promote certain sets of certain assets that are deemed as certified or reliable. There is, I think, other than that, so I think there was an implementation of tags, and it was contentious. Not everyone likes tags, so I think it's behind a feature flag, and I'm not sure what the exact level of support for tags is currently, but we worked on that while I was at Lyft. And I believe like folks at Airbnb rightfully were like, tags are messy, everyone likes tags. They're kind of many to many nature, kind of leads to inconsistencies. So we wanted to consider other things. Another idea, I think that's a really good idea. That's my personal favorite area, and the curation is the idea to bring a new native dashboard component that would be a set of objects. So that means inside a dashboard, you could bring like rich set of objects, other charts, other dashboards that are referenced in there, so that you can think of a dashboard as a curated list of items, right? That can mix list of objects. So it could be like, hey, maybe there's a finance team disambiguation dashboard that shows all the assets that are related to finance, plus on the key charts, some markdowns around like how to orient yourself. So that makes the dashboard a kind of a folder in some ways where you can find other assets. So that does not exist today, but that's an idea, right? This idea of like object collections as a native dashboard component. Cool. Earlier, I think I got disconnected. I was having, I'm not sure when I got disconnected. My router here is not so great, so I got disconnected randomly. But I was talking about like, is BigQuery, like how does BigQuery kind of relate to Presto in some ways, and is that a data lake engine? And looking into the different options as you create external tables in BigQuery, much like Presto, you can latch onto Bigtable, you can latch onto Parquet files, Avro files, JSON what was it called? JSON L, I think. It's like line broken kind of JSON files. You can also connect to drives, Google Drive, as well as Google Sheets. So starting to look a lot to me like Presto on top of S3 is just more BigQuery on top of GCS.
Yeah, it is interesting. Like, I don't have a ton of experience working with sort of like data lake engines, and I'm kind of curious like how Presto, Trino, vendor-specific services like Athena really stack up against each other in terms of like feature and performance. I think that would be like kind of an interesting topic to explore in the future, especially because I mean, data lake architectures just seem to be growing in importance and in prevalence because they're just so flexible and cost effective, and they scale really well with an organization. So yeah, that could be a cool topic to explore in the future.
For sure, Presto and Trino, being a fork of the same original project, I think they're more alike than different, but it's unclear to me
for sure,
like,
right now.
What are the strengths and weaknesses to like, what is the nature of the diff in that fork, right? I'd be curious to learn more about that. But in terms of like how these engine, also like when you go to a cloud provided service like Athena, like do you lose on some of the flexibility of like installing whatever SerDes you want? By SerDes I mean like there's serializer, deserializer, which are the ways that these like federated data engines can query different sources, right? So there's this whole array of SerDes from the basic Parquet, Avro, ORC. But then there's the more funky ones where you can have Presto query something like Druid and query maybe something like HBase inside this query engine and do joins across these systems and inside that federated layer, which is really powerful and interesting. So curious how the cloud provided services like Athena, whether you loosen that flexibility of using whatever SerDes you might want.
Cool. Someone asked a question. Hi, Robert. Nice to see you. It's nice to see you too. Glad to see that you're here. Thanks. Wow, that was really nice. All right. So I think we're about at time. I'm going to hang out for another 5 or 10 minutes and just answer any other questions that pop up. But definitely, Max, I mean, feel free to hang out if you want to. Don't feel obligated to, of course. Yeah, it was great to just kind of talk with everybody and talk a little bit about data lake architectures. Hopefully I will have some internal projects that I can share relatively soon from work at Preset that involve data lakes that might be interesting to blog about. But yeah, my experience with data lakes is relatively immature. Like I've started working with them fairly recently, and I'm actually pretty enamored with them just because of like the cost and the scalability and just how flexible they are is really attractive. Now we got a couple other questions popping up in chat, so I'm going to take this as an opportunity to go through those. So one person says, it's me here, a feature I haven't been able to figure out in Superset. How can one show pre-calculated KPIs on a line chart or time series chart that don't require any aggregation? Is this something provided by Preset and not available in the open source Superset? So the second part of that question I can take really, really easily, which is as of right now, Preset is not like a special tricked out fork of Superset. It like the effort that Preset has been putting into Superset has been going into Superset. And so as a result, Preset's version of Superset and Superset are right now very similar. There's no like special feature there. For the first part of the question, I don't know, Max, do you have thoughts on that?
Yes. So here, the person wants to do doesn't want to apply aggregation, basically. So when you think about our data explorer and Superset, the no code explorer, that's the place where you slice and dice the data. For us to be able to do that, it's based on the assumption that your metrics are aggregated expression, aggregatable expressions, things like sums and averages. If you do happen to be in a case where you're not interested in grouping, grouping really doesn't matter, right? The sum of a single thing is really just that thing. So in that case, you effectively want to group by the one, maybe you have a very simple table that's like country and population, right? And all you want to do is look at the population per country. Superset will emit a group by, a sum of population group by country, which effectively gives you the exact same data set that you have without aggregation. Where this becomes interesting is like as you add more columns, like genders and other demographics, that enables us to like slice and dice and kind of pivot the cube and look at different dimensions and breakdowns. So that assumption is pretty deeply baked in. And it's generally not an issue, right? Like you could argue that there's a database operation that's unnecessary here that's getting done, the grouping when you're already at the right grain. But it's no big deal because it's a cheap operation. So I'm not sure if that answers the question well. I'm not sure if there's another reason why you might not want to group here, but that's generally the answer for this.
I see Luis has kind of an interesting general question, which is, are there any storage services that Apache Superset performs better with than others? So if we're talking about storage services as in like bulk file storage, so like S3 versus like BigQuery versus other things, like at the end of the day, it really just comes down to the performance of the underlying storage. I don't think that like everything goes through SQL Alchemy. There isn't a special like increase in performance that you get by using one or another from Superset's perspective. It mostly just comes down to how fast the queries are being executed on the underlying data. Hopefully that answers that question. Mark actually asks an interesting question. He says, when I run the Docker image, the version is 0.9990 dev. How can I get the 1.x version running using Docker? This is a common point of confusion. It basically always, the Docker version will show 0.9990 dev in the UI that does not have a relationship to the underlying version of Superset that's running. So if you're running the latest Docker image, you should be running 1.1 point something. So yeah, hopefully that clears that up. Vishav asks, can we embed Superset dashboard or charts into third-party portals or websites or mobile applications like other BI tools? Power BI has features to embed dashboards and visualizations into third-party portals or web and mobile applications. This is a really good question. The embedded use case is something that a lot of people ask about, and it's something that we're thinking about really, really actively. I think it's like a pretty high priority roadmap item. I don't know if Max, if you want to add something about the embedded use case.
Yeah, I mean, I want to say that it's possible today to, from the Explorer, there's a little embed button where you can get an iframe tag that you can paste some other place to embed your chart. You can pick the width and height. It's fairly simple, rudimentary, right? In terms of like, it will just embed the chart as is without any interactivity components. It's also possible to do it on the dashboard side of things, where you just, wrap the dashboard URL into an iframe. And there is a little trick there. I'm not sure how well documented that is, where you write, question mark standalone is equal to true, where it will remove the menu from the top because you just want your dashboard. You don't want like that Superset menu at the top.
That's a good one.
Yeah, I don't know how well documented. We should put in an FAQ if it's not in there already. But
yeah, I'll actually make a note of it.
Yeah, so we're looking to improve the iframe side of things on one front, right? To be able to embed an interactive charts where we would enable you to bring, the left panel in the Explorer where you can pick your metric, pick your group by, pick your filtering criteria, pick your time filter. This we would enable you to bring that left panel and embed that into your application as well and specify which controls you want to expose to your audience, right? Because you might not want to expose the 20, 30 different controls. You might just want to pick 4 or 5 that you want to let people use. So that's part of the vision on the iframe side of things. And then we're really thinking about having much more of an SDK, like something like a React toolkit, where so that's much more an SDK or for app developers, where instead of just jamming an iframe into your application, here you would be importing the JavaScript library and then using React or JavaScript components. So that's down the line, probably like 3 to 6 months horizon or so.
Awesome. Thanks for that view. There's another kind of interesting one that popped up here, which is with Superset, can you create a centralized metrics layer? I'm using SQL Server Analysis Service. I can create the semantic layer, which really defines all the measures and dimensions for user to access. Wonder if Superset offers this capability so that we only define once and use any report. I'm not sure that I fully understand that question. Max,
I think I do. Yeah. Well,
Okay.
so there's this idea in BI tools called a semantic layer, and they're basically what the business intelligence tool or what the platform knows about your data structures and data sets. So it will know things like, what are the tables and how can they be joined, and what's their pretty labels we should use, and what's the default formatting for this metric, or should it be a percentage sign, or should it be 3 digits after the comma. So all of this, so this semantic layer becomes somewhat of a menu for users to pick from when they try to build charts, right? So it's really just this abstraction layer on top of your database that makes the BI tool act better. So we do have one. So the dataset editor in Superset is our semantic layer. So it's a pointer to a table, a view, or a query. And then you can define calculated dimensions as well as metrics, right? And you can put pretty labels and things like that. We're really looking to improve our semantic layer to add the notion of joins into it. So that means like the data set construct will become richer over time. In terms of philosophy, I think it's really important for the semantic layer to not get in the way, right? Like when you have a table, you want to make a chart, we just want to take you there. Maybe over time, you want to progressively improve your semantic layer, put nice labels, add some calculated dimensions that are super useful. So I think that's the general philosophy here. I'm not sure for exactly which feature of the semantic layer you're talking about here in the question, right? But it's generally this idea of like curating a list of metrics and dimensions so people can self-serve with like nice little labels and nice descriptions so they really understand what they're doing. And it's possible to do that today in Superset in a lot of ways. And we'll improve that layer so it can do joins. I forgot what other improvements we're looking at, but things like spatial dimensions, which might be lat long column or geohash. So to really tell the semantic layer, hey, this table here, this data set has spatial constructs, so that when you use the DECGL charts or the geospatial charts, then these like spatial construct can be reused without having to think about lat long or like whether you're using a geohash or something like that. So much improvements. I think there's going to be 2 SIPs coming through on the semantic layer soon. So look up for that. You can filter in the issue list on the GitHub repo for SIPs. And I think Beto, who's a fellow committer on the project, is going to be publishing that soon. So looking for feedback on that front.
Awesome. I think I got about time for one more-ish question. Also, if your question didn't get answered or you want to just talk about this more, come on over to the Superset Slack. You can find me, you can find Max, you can find all of us hanging out there pretty much all the time. Happy to take more questions there. Mark just asks a quick general question about Superset, which is he's backing up Superset using pgdump and restoring using PSQL. It doesn't include the dashboards, and he has to manually import and export them. Is there a better way? So in general, I think this is a question about what is the best way to export like a whole Superset instance, including the dashboards, the charts, the custom SQL queries, all of that stuff. I don't think Superset currently has like a simple export feature for everything or an import feature for everything. Do you know if that's like something we're planning soon, Max, or do you have anything about that?
So the first thing I want to say is the metadata database has all the metadata that that Superset has, except short of the caching for loading dashboards fast in terms of like just the caching of the data itself. But
That's true.
The metadata database should have everything, including the dashboards, the chart definition, the query definition, the users, the RBAC, like all of this should be in the metadata database. So if you export that, if you back that up and restore it, you should find it as it was at the time of backup. In terms of the export, currently we've been working on the import export framework. Same person I just mentioned, same committer I just mentioned. So Beto has been worked on that, I think more on the November, December last year. And now we're at a place where when you export assets, it makes nice little tarballs of YAML files that are very intelligible and readable with nice UUIDs and things so that it all works well. Not all object types are exportable currently, but that's probably an area where people could contribute. But I know for sure that like the key things that are really important, like charts, dashboards, queries, data sets are all exportable. And if you do export a dashboard, you're effectively exporting all the dependencies of that object. So that means collection of charts and data sets that relate to that dashboard. So you should be able to go to the, so if you're using the latest superset or fairly recent one, you go to the dashboard page and you click select all and click export, and you should get like a big tarball with all your objects that you can restore in a different place. I think there was something else to say is in the future, we might be interested to allow for people to manage dashboards as code or as static objects. So you could see how certain dashboards and objects would be living in source control. And that means that then you wouldn't be able to edit them in the UI. But for these like highly curated, like super key data sets, that's a request we've had in the past of saying like, lock this up, don't let people change it. It's defined as code, it's in source control. So that will be, that's an upcoming feature as well.
All right, I think that's about all we have as far as time. Thank you everybody for attending. It was a real pleasure to just hang out and get to talk about this stuff. Thanks, Max. Thanks, Srini, for dropping by and answering questions. And yeah, I'll see you all next time. Thanks for coming by. Have a great rest of the day, everybody.